Okay, and we are back after the break. Before we move to the next session, let's take a look at our virtual mural. It's coming very nicely. So if you haven't put your photo in, I encourage you to do so. And if you did, of course you can put more. Okay, so the second session for today will be machine intelligence session 1. The topics will include sentiment analysis, weather classification, and drones. And regarding drones, have you heard about Amazon's plan to make intercontinental shipments using electric submarine drones? I think it will probably cause a large increase in efficiency. So as the efficiency goes, I am sure that the next session will go very efficient with the chair, Dr. Rana Hamad Raza from the National University of Science and Technology in Pakistan. Welcome, Dr. Raza. How are you?
Dr. Cesari, nice to see you here.
It's nice to see you again next year. What's the weather in Pakistan?
It's a bit cold in here, but the place where I am in right now, Karachi, it's a little mild right now, maybe probably around 26, 25 degrees right now at this centigrade.
Okay, so it's for the standards here in Poland, it's very hot because we have about -5 currently, and there's the snow, so there is winter, very nice winter in Poland. Okay, so the floor is yours. We can start with the session.
Hi everybody. Thanks, Dr. Cesari, for a quick connecting up with me. It's nice to see you all here. I'm sure everybody must be excited to attend this MIDI Conference 2021. Now, just a quick some instructions which I have to impart being a session chair, so that I can actually give some instructions to the authors that you have to actually, just a quick reminder that this will be a session of 1 hour and 15 minutes. Since we will be following asynchronous mode, that means the video will be played. So all presentations for the sessions are pre-recorded, and the video presentations will be played accordingly. Before the video presentation starts, the presenting authors are requested to switch on their cameras, and after the presentation, screen sharing will be stopped and authors will be unmuted. Accordingly, the authors will present and introduce themselves by sharing their name, institution, country, and the background. After each video presentation, we will have a live question and answer session. The chat will be opened during the session, and I encourage all the conference audience to ask questions and share their opinions on the chat. And it will be best if you can write your questions on the chat. You're welcome to come on the audio as well, but it is more understandable for all the audience that what is the question, so that we do not bog down due to the accent or due to any of the dialect we have, so that we capture the question properly, and accordingly we can get the answer from the authors. Coming back, I will keep a track of the time to remain within the session schedule. There will be breakout rooms for the participants for extended questions and to interact with the presenters and with all other participants, those who are available and joining. One last thing, that the presenters have to click the join audio button before they can be unmuted. So this was a little bit instructions which I had to impart being a session chair as guided to me by the conference organizers. This session will have around 4 presentations. So formally we will start the very first presentation, that is regarding weather classification with transfer learning. They have used Inception V3, MobileNet V2, and ResNet 50 in their paper. So this is a deep learning intensive paper, and it is being presented by Mr. Patrick Mojanowski. Excuse me if I've not pronounced your name correctly, but Let's play the presentation, Mr. Bartos, please.
Hello, my name is Mojanowski and I will present the results of my research on the use of convolutional neural networks in weather classification problem. I have built a few models based on Inception v3, MobileNet v2 and ResNet 50 architectures and compared their metrics. When we think about AI and weather, the very first thing that comes to mind is a forecasting. But what if we want to determine the current weather condition? Of course we can use weather stations, but it can be a bit costly. When looking for an alternative solution, it is worth asking whether is it possible to use convolutional neural networks for this purpose and how will the popular machine learning algorithms deal with weather classification problem. I tried to answer these questions in my paper. Classifying weather in this way can be difficult for CNNs, because it is difficult to describe weather phenomena such as rain, fog or lightning. They have no shape and may appear in the image as fragmented elements like raindrops. In extreme cases, they may be similar to each other. Very intense rain can resemble fog. As a result of the research, 3 models were created, based on Inception v3, MobileNet v2 and ResNet 50 architectures. They were chosen to compare due to the significant differences in architecture and the availability of base models. The transfer learning technique was used. A pre-trained model from the TensorFlow hub was obtained for each network. In order to minimize the impact of base models on the final results, selected base models were trained on the same dataset, ImageNet. The set of training data was built on the basis of 1577 images with dimensions of 512 by 512 pixels. Input images were JPEG files. Each training image has been assigned to one of 6 categories. Clouds included 19% of images, fog 12.8%, rain 13.6%, shine 16%, storm 16%, sunrise 22.6%. The dataset was built using the web scraping technique of the results of popular search engines. Images were manually selected for compliance with the potential label. The data has been normalized to the appropriate dimensions. The project uses the ML.NET framework. All the source code for training and validation was written in the C# programming language. Using the base models, a separate model was created for each algorithm. The division of the dataset into training and validation data was made using the cross-validation with 10 numbers of faults. In other words, 90% of the images were allocated to the training set and the 10% to the validation set. The training algorithm was run with value of batch size set to 10, epoch set to 200 and the learning rate set to 0.01. After the validation stage, the results indicated the advantage of MobileNet v2. ResNet 50 was in the second place and Inception v3 was the worst. The average micro accuracy was 0.826 for Inception v3, 0.878 for ResNet 50 and 0.909 for MobileNet v2. Additionally, the models were tested with 2 other datasets. Images from the experimental sets were not used in the learning process. The first dataset contained 37 low-resolution images of all 6 categories of classification. This dataset included images in which the assessment of atmospheric conditions could be problematic. The second dataset contained 1,125 high-resolution images of 4 categories: clouds, rain, shine, and sunrise. There were no fog or storm images in this dataset. The first dataset metrics show that on difficult data, MobileNet V2 performed worse than Inception V3 and ResNet 50, which achieved the same average accuracy. MobileNet V2 had the best classification time. It was almost 4 times faster than Inception and ResNet. MobileNet V2 did best in the second experiment, achieving the highest accuracy and the best classification time. All models achieved an acceptable level of accuracy, 70% to 73% in the first experimental dataset analysis and 95% to 97% in the second experimental dataset analysis. The research shows that neural networks can prove themselves in the problem of weather classification. The possibility of multiple weather conditions at the same time should be taken into account. Another problem is the similarity of certain weather phenomena. Fog and rain can become indistinguishable with insufficiently good image quality. The source code is publicly available on the GitHub platform.
Please, if you can. Thank you, Patrick. I hope you can hear me, dear. Please, if you can switch on the camera and maybe we can have a little question and answer session regarding your paper. And the audience is encouraged to have the question and answers regarding the paper. It is a very interesting topic, which is weather classification. So any questions from the audience, please? Patrick, if you can switch on the camera.
Ladies and gentlemen, it's a great pleasure to be here and answering your questions. Please confirm that you can hear me.
I can hear you, Bartos.
Can you hear me? Excuse me.
Yep, I can hear you.
Okay, thank you. First of all, please forgive me, no video, but unfortunately my camera was damaged by my son 2 weeks ago, just before I recorded the presentation. But I hope to get a new one from the Santa for a good behavior. So I will answer the questions which are on the chat.
First question is from Mr. Tomaz. Did you ever try ResNet 100 in your paper?
No, I choose those 3 architectures because they've got significant differences in the architectures. The main purpose was to compare architectures from the different families. Yes, so I choose the ResNet 50 as the representative of the ResNet family.
Okay, again, the second question from Rua is again quite similar. That why do you think a certain network perform better than another? What is the basically the criteria that you have used for selecting these networks and how you can compare them with each other?
First of all, I compared the results, the empiric results, based on the experimental datasets, two datasets. One of them was pretty complicated, pretty complex, and the MobileNet V2 performs the best.
Okay, again, there is another question by Autumn, that why not you can use RNNs, which are the recurrent neural networks, for forecasting. That seems to be more natural for predicting future results.
My paper was not about forecasting. It was rather for nowcasting. It was about determining the current weather. The forecasting is a different problem. Yeah.
I hope Mr. Autumn has got the question. I skipped one, I think missed one of the question by Mr. Adam, that how the hyperparameters have been chosen. How have you selected your hyperparameters for your architecture here?
The hyperparameters was chosen based on the research I've done, how to prepare models. They were default and very popular setup for creating models, and unfortunately I have no computing power to experiment a lot with the different setups and so on. So I use the defaults that perform very well in the different kind of problems.
You have been testing in that it has been the lab testing data that you have actually, the training data set that you have experienced in the lab that you have actually used for your paper, right?
Yes, another tests I have done, but I haven't described it in my paper, was to take my DSLR camera and point it on my window and observing the results, and it was pretty good.
That's great. I have a question from you, which I have written here, that what is the effect of pre-processing techniques, if you have used it, regarding the image size reduction, image normalization, etc.? If you can highlight some details about that, dear.
Yes, well, image preprocessing is a common technique used in the machine learning, but as I state in my presentation and in my paper, ML.NET framework that I used doesn't require this, but I have done it because it's a good practice, but it's not necessary.
Okay. Any other questions from Mr. Patrick from the audience, please? I think we are all set. Thanks, Patrick, for your time and presenting to us during this session. It has been an enjoyable presentation. And we move over to the next presentation, which is which is our second presentation. And let me just quickly pick up the right note, which is in front of me, which is a course to find multi-class object detection in the drone images using convolution neural networks. This is being presented by Rua Aburasin, and the paper co-authors are E.A. Adrissine and Majdi Zameen. So if you can play the...
Hi, everyone. I would like to start by welcoming everyone here in this conference, and I'm pleased to present my paper today, which titled as A Course to Find Multi-Class Object Detection in Drone Images Using Convolutional Neural Network. First of all, I would like to give you a brief introduction about this research. As you may know, the multi-class object detection has undergone a rapid evolution in the last few years due to the developed CNN architectures as well as the high-resolution ground-level images as in COCO and VOG datasets. So this amount of data enable the researchers and practitioners to train the deep CNN architectures and reduce the loss of the model. At the same time, the drone's availability is increased nowadays, and it has a great potential in improving the surveillance of large ground areas for security and economic purposes. In this research, we have given a collection of large images captured by a drone flown at a fixed altitude in a desert area located in United Arab Emirates, and we have used this dataset to investigate the applicability of CNN architectures in detecting the objects. So what are the challenges in the drone images compared to the regular images or the ground level images? First of all, the aviation regulations enforce the drone to flown at a high altitude, which make the objects look very small and low in resolution, which make the features looks in the image are very limited to distinguish between different objects. Also, training a CNN architecture require a lot of data to train the model, which are not available in the given dataset. We are given only 221 images to train the model. So this is the most important problems we face in the dataset. The features, because the drone flown at a high altitude, it shows only the top view of the image, because the top level, or let's say the top view of the image, don't show the discriminative features that can be used to distinguish between different objects. So the data set we have given is very low in resolution. The top view only shown in the objects. We try to use only these features to distinguish between different objects. In this paper, we have present an intensive literature review about the CNN architecture and how they are differ from each others. As you may know, the architectures used in the detection task is actually an extension of the architecture used in image classification. That's why we have started the literature review by reviewing most of the CNN architectures that have been used for the recognition and classification tasks, such as LeNet, AlexNet, ZFNet, and so on. So all these architectures, we have tried to give the reader a brief introduction about each architecture and show how they are different from each other. For the detection task, because the detection is an extension of the CNN architecture used in the classification task, there are two approaches actually, two-stage object detection and one stage. We have also compared these two approaches and show most relevant works that can give the reader an intention about how to select the appropriate architecture for a particular application need. In this research, also, we have shown in the literature review the 3 different applications available in the literature for using the drone images for different applications. So you will find all this information in the paper, and you can find how our research is different from other researches. Because most, even if the drones images have been used in literature before for detecting different objects, they use the CNN architecture as a black box. They didn't discuss how and why a certain architecture can perform in a particular data set better than another. So all these technical details we have investigated in the paper, and we discuss it to give the reader an intention about how to select the appropriate architecture. The contribution in this research are as follows. First of all, we have selected 3 CNN architectures to train the model, which are SSD 500 with VGG-net meta architecture, SSD 500 with ResNet meta architecture, and also yellow version 3 with DarkNet 53 meta architecture for training the model. So we compare these 3 architectures as it is. We didn't change any parameters. We take the model as a black box and train the model, train the data set. Then we have find that yellow version 3 outperformed the other 3 models, the other 2 models. So we have selected this architecture for further investigation. We have studied the impact of the learning rate, how the learning rate may improve the result, also the optimization method, the pooling type in the architecture, as well as the optimization method. All these details can be found in the paper. You can find a lot of details about why we think these parameters can improve the result and what are the best value for such parameter and why. All this discussion, you will find it in the paper. Finally, we have developed a model has a precision of 0.99, a recall of 9.4, and F-score of 9.6, which was optimal for a real application need. And the PELT model is currently used by some companies for detecting objects in real time. So this is actually how the research dataset looks like. The dataset comprises of 221 images with this size, and it's captured by a drone. In the paper, we have discussed how we configured this dataset and what are the pre-processing steps we conducted to make the images suitable for training a CNN architecture. There is one important strategy applied to the dataset, which is data balancing strategy. You can find all the details about this particular strategy, as it was the most important point in improving our initial result. So we have used a single shot based training approach. We have heavily investigate the CNN architectures with different number of layers, with different type of pooling layers, with different optimization method. We have investigated the activation function, how it may affect the result, the learning rate, the optimization method. All these details are investigated, and we have shown in the paper how they affect the performance. Finally, we have selected the best choice of the learning rate, the optimization method, and the pooling type, and we combine all these values in a model to find the model. So first of all, we investigate each one separately, and then we have select the best value for each of these parameters, and we retrain the model, and we have received this optimal solution for our problem. So this is the sample of the result. This is how the model capable to recognize and differentiate between objects in the given data set. Currently, the PELT model are used by Falcon Eye Drone Ltd and United Arab Emirates for surveillance purposes. And that's all. Thank you for listening.
Thanks, Rua, for presenting your work. It's really interesting. If you can please switch on your cameras and the co-authors if you want to join in, that would be great, dear.
Yeah, is it okay now?
I can see you, dear. We're just waiting for some questions from the audience. If you want to ask questions from Rua, she is available. So you can type your questions in the box, in the chat box. We'll wait for another 4 to 5 seconds. Otherwise, I'll start asking you a few questions there. I think there are no questions coming from the audience. So I have a question from you, Rua. What was the impact of varying the number of convolution layers in the selected small and large CNN networks? If you can.
Actually, it depends on the data set, because we have a very small data set. If we have a very large convolutional neural network with a lot of layers, it will increase the overfitting of the model, because it will not able to reduce the weight upon the iterations. So that's why the number of layers, if we have a very long, deep neural network, that means we should have a lot of images to train the model. So that's why reducing the number of convolutional layers, if we have a very small data set, can reduce the overfitting and perform better.
Okay. So if you can just give me, have you implemented this for any real-time use case?
Yes, the drone images is actually real case, because the drone flown at an existing area here in Gulf countries, and they give us this data set for because they want a real application. So we use this data set for training and evaluation.
Okay, so have you studied this from the concept of a computation time? Like how much time?
No, we don't consider it at all, because we want to improve the result. We have a lot of failure attempt to get the model work. We have a lot of loss at the beginning of training the model. So that's why we try to improve the result rather than focusing on the time, because there is no model trained before in a similar data set. So we can't apply the transfer learning immediately and continue to back propagate on our data set. So we have to focus on improving the result. Because also when we try to detect different classes, at the beginning, we only, in the last year, I present a paper with a single class, because at that time, the multi-class didn't work at all.
Okay.
So we just focus on improving the result.
Okay, thank you, Rua. We are just waiting if there are any questions from the audience. I think there are no questions coming still. Let me ask you another question. During the data balancing process, Rua, how you authors have ensured that there is no duplication of the training data, because this is the complex data to work on.
Can you repeat it, please?
During the balancing process, how you have ensured that there is no duplication of data in the training process?
Because we didn't use the same images. For example, if I have this image, which consists of 3 classes, okay? So I use this image for one class. I didn't use it in the other classes data set.
Okay.
Yeah.
I think that's it from my side. There are no other questions coming from the audience. So thank you, Rua, for interesting presentation and your research paper and presenting it so well.
Okay, thank you very much. Thank you.
With this, we move on to our third presentation, which is regarding the sentiment analysis using state-of-the-art machine learning techniques. It is being presented by Salih Balki, and the paper co-authors are Gozde Marv and Helmi Demiran and Saleh Sarp. So please, I'll ask my technical host, Mr. Bartos, if you can play the presentation of the authors, please.
Hello everybody, I am Salih Balci. I am doing master degree at Kebs Technical University. Today I would like to talk about our study, sentiment analysis using state-of-the-art machine learning techniques. Myself, Mrs. Demirci, Mr. Demirhan and Mr. Sarp collaborated in this study. I will share the general outline of this study. First, I would like to talk about the objectives of this study. Then I will introduce sentiment analysis with background information. I will talk about the state-of-the-art sentiment analysis techniques, which are LSTM, bag of tricks, CNN, and transformers. Then I will share the results. Finally, I will conclude the study. Objectives of this study. Sentiment analysis is one of the essential and challenging tasks in the artificial intelligence field due to the complexity of the languages. Models that use rule-based and machine learning-based techniques have become popular. However, existing models have been underperforming in classification of irony, sarcasm, and subjectivity in the text. In this paper, our aim to deploy and evaluate the performances of the state-of-the-art machine learning sentiment analysis techniques. On a public IMDb dataset, the dataset includes many samples of irony and sarcasm. LSTM, BOT, and CNN and transformer-based models are developed and evaluated. In addition, we have examined the effects of the hyperparameters on the accuracy of the models. Background information. First of all, I will talk about dataset. The data used in this study are taken from the public IMDb dataset. It has binary labeled 50,000 reviews. To train the sentiment analysis models, 35% reviews are chosen for training, 15% for validation, and 50% for testing purposes. Secondly, pre-processing. The abundance of text data provides many opportunities for training the natural language processing models. However, The unstructured nature of the text data requires pre-processing. Lowercasing, spelling corrections, punctuation, and stop word removal are some of these pre-processing steps. In Python language, these operations could be easily implemented using NumPy, Pandas, TextBlob, or NLTK libraries. In addition to these, tokenization, stemming, and lemmatization process are realized to convert raw text data to a more understandable format. The last one, feature engineering. After pre-processing, feature extraction steps are implemented to transform words or characters to computer understandable format. This step includes vectorization of words, which provides corresponding vectors for future processing. State-of-the-art sentiment analysis techniques. First of all, LSTM-based sentiment analysis. Long short-term memory architecture is an improved version of the recurrent neural network to overcome the vanishing gradient problem with an extra recurrent state called a memory cell. LSTM achieves long-range data series learning, which makes it a suitable technique for a sentiment analysis task. To increase the performance of the LSTM-based model, forward and backward RNNs are combined to form a singular tensor. In addition to bidirectional, multiple LSTM layers could be stacked on top of each other to further increase the performance. We have used 2 layers of LSTM and 0.5 dropout on hidden states for regularization to decrease the probability of overfitting. Secondly, bag-of-tricks-based sentiment analysis. Among deep learning techniques, linear classifier could achieve similar performances with a simpler design. However, one of the disadvantages of linear classifier is their inability to share the parameters among features and classes. The bag-of-tricks architecture uses linear models with a rank constraint and a fast loss approximation as a base. In this study, bag-of-n-grams such as bigrams are utilized instead of word order for higher performance, where the n-grams technique stores an adjacent words together. Third of all, CNN-based sentiment analysis has a multi-layered feed-forward neural network architecture. It aims to reduce the data into a shape so that it doesn't lose any features while processing. This way, CNN makes sure that the prediction accuracy and quality will be higher. In this study, convolutional layers will be used as a key. Consecutive words is a piece of text. One times key filter will be used to focus on key consecutive words as in bigrams, trigrams, or n-grams inside the text. The last one is the transformer-based sentiment analysis. The transformer is a state-of-the-art network architecture proposed in 2017. In this state-of-the-art approach, the results shown that with the use of a transformer, natural language processing tasks outperformed other techniques. In the study, we used the transformers library to obtain the pre-trained batch model, which is employed as our embedding layers with the pre-trained architecture itself. We only train the rest of the model, which learns from transformers representations. I will share the results. The training time comparisons of state-of-the-art models are indicated in Table 4. The results indicated that most of the deep learning models provide reasonable training time except the transformer-based model. Even though only time analysis doesn't give a concrete interpretation of a model, we see that there is a huge time efficiency difference between BERT and other models. Validation and test losses results. Validation loss is another important metric to evaluate how a model fits new data. Validation loss is also a good indicator of overfitting. The validation, training, and test losses of the models are shown in Figure 4 and Table 5 respectively. The loss graph of the transformer-based model indicates that it could converge faster than other models with a fewer number of training epochs. This will be a result of pre-training of the transformer model. Validation accuracy result. Validation accuracy is combination with validation loss could be used to determine the generalization ability of the model. The validation and testing accuracies of the models are given in Table 6. Validation accuracy reveals that 5 epochs of training is enough to get reasonable results, which are also in line with the validation loss as well. Testing accuracies are aligned with the validation accuracies where transformer-based model achieves the best performance. Observations derived from the performance comparisons are outlined as you see. First observations, bag of tricks based model is faster than other deep learning models. Second observation is transformer based model takes a long time to train and predict. Third observation is optimum number of epochs could be determined using accuracy and loss of training and validation phases. 5 epochs of training provide optimum training. Last observation, transformer-based model converges faster than other models. As a conclusion, sentiment analysis has been studied to harness the reviews, comments, as well as other written documents. The potential of sentiment analysis provided many benefits to various industries, such as entertainment and e-commerce. This paper presents sentiment analysis models that utilize 4 different machine learning techniques such as LSTM, bag of tricks, CNN, and transformers. Their performances in terms of time, loss, and accuracy are examined and compared. The bag of tricks based sentiment analysis model is faster than other machine learning models, where the transformer-based model performs poorly in terms of time. Furthermore, this study also demonstrates the accuracies of these models. The transformer-based sentiment analysis model achieved higher accuracy in comparison to other machine learning models. Thank you for listening. Please don't hesitate any questions.
On your camera so that if you wish to, we can see you. Do we have any questions coming from the audience so that we can ask some interesting questions from Mr. Saleh regarding his paper? We'll wait for another 2 to 3 minutes, 2 to 3 seconds. And if you don't get any, then I'll ask you questions.
I can't hear your voice, but can you hear me?
Yes, Saleh, can you hear me now?
Yes, I can hear you now. Okay. I have no computer-based background. I'm a mechanical engineer, but now I am doing some research in that area, and also I would like to apply these techniques, also deep learning techniques in the future in my mother language as a Turkish, because there are lots of algorithm and also data set for English in English, but there is no data set or maybe usable algorithm for my mother languages, because the language is so different. As we are waiting a question, I would like to say that.
So there is a question from Mr. Ahmed Al-Aziz that when doing sentiment analysis, how do you account for factors like sarcasm?
Yeah, this is the most challenging task, the sarcasm. There is a lot of sarcasm in this data set, in EMDB data set, but we didn't focus for the sarcasm. Sarcasm, maybe we can do some implementation for the sarcasm in English, but there is no useful algorithm or something for my mother languages as well. Especially, I would like to focus in that area in the future. Thank you for the question.
Any other question from the audience, please?
Thank you for listening and asking questions.
Saleh, I have a question which I have written down here for you. By the time we get some more questions, like, have you
yeah, definitely.
between validation data percentage while reducing the test data? Like, I'll go one by one. So I've just written down 3 of them here. So if you can answer one by one each of them, that would be great.
I've just seen a paper using 50% for the testing is not good for me. This is not a good idea, but I just figure out after the writing paper, applying the paper. Maybe in the future, I would like to use less testing data. Maybe it's the best one is maybe 60%, maybe 60% for training, and the other is comparing testing and validation. This one is my first paper and first implementation for this area. Thank you for question.
The next one is what was the evaluation criteria of the proposed methodology? If you can just, other than the accuracy one, like you have focused on the accuracy, have you considered any other criteria of assessing the quality of your results that you are getting?
Actually, maybe we can use some fine-tuning, and also I got best result. For example, in transformers, I got 90 accuracy was 94%, but I didn't write the paper because the result is from just getting caller. On my computer, I'm getting the best result, but I haven't used that one because it's not everybody can see that result. In the future, I will increase using some fine tuning, and also we can change some tokenization methods. Maybe we can increase our accuracy. Okay, also, at this time, I got 96% accuracy in BERT model. I will publish in the future. Thank you very much.
That's great, dear. The last one probably, which is of interest to me as well, that what is the reason for a quick convergence of the model in just like 5 epochs that you have given in your concluding slide?
Actually, it was enough just 5 epochs, but I would like to show the readers there is nothing to change after the continue doing some process.
Okay. Okay, thanks for your interesting presentation and the questions, and we wish you success in your future endeavors. From there, we move on to our last presentation of this session, which is regarding the causal inference time series. It is being presented by Mr. Ashwarya Ashish. I'll request my technical host, Mr. Batos, to please play the presentation of causal inference time series.
So the current research is about causal inference, and it's related to time series, how we can find different results and infer from it. And this is based on a very interesting data set. So yeah, let's just get into details about it. So basically, detecting causation in observational data is a very difficult task, and it has been in the highlights of research for a long while. And identifying the causative direction, coupling delays, and causation chain from time series may be used to find causation relationships, but it doesn't really infer the exact things that we observe, and it might infer something else. And that's the thing we are trying to figure out here. So 3 issues must be addressed when inferring causality, and it's basically resilience to noisy time series, what's the computation efficiency, and seamless causation inference from high dimensional data. And in this research, we aim to provide empirical evidence on the relationship of Marvel Cinematic Universe, the movies and the Marvel comic book sales using Fourier transform, and cross correlation of 2 different time series data. And this is the first of its kind study, which establishes some concrete evidence on whether the trend of declining comic study and increasing movie audience will disrupt in the post-COVID world. Let's talk about data sources. So the project takes data from 2 different sources. For the comic book sales figure, we are taking data from Universal Repository of Comicon, which is basically an internet database featuring monthly comic book sales. And for the movie earnings, the data is collected from Universal Machine Learning Repository. For all-time domestic movie sales, Box Office Mojo, that's the internet database giving various data related to movies, including box office earnings over time, is used. Talking about the trends, from what we get through the data, Marvel Comics profit as a time series T in months since Jan 2008 is you can see that in the left panel, and in the right panel you can see total Marvel Cinematic Universe domestic box office profits as a function of time. So this basically defines that there is something going on, because you see some spikes, some dips, and that may be due to different marketing campaigns that go, and also at what time the comics are released and at what time the movies are released. So maybe when a movie is released, the comic sales go up, or maybe it declines a bit. We'll find out. Going forward with some of the procedures that we used, filtering. So raw comic book revenues and a degree of phi polynomial fit is observed in here, and when we subtract the polynomial trend from the raw data to get detrended time series, then we get what's shown in the right panel. So with trend we see some seasonality, and that seasonality occurs every month, because some months is going down, it's taking a dip, and some months is going up with a spike. But when we detrend it, we see just the data with errors, and error series and trend series. So going forward with cross correlation, the Marvel Comic Universe earning dataset and the Marvel Comics dataset, cross correlation as a function of tau, and the time series shift. So peaks defined a high correlation. So you can see there are around like 12, 13 peaks that come in this data. And what that really means that like when the peaks are there, the both the kind of data are highly correlated, and we can like obviously drive some research to investigate the fluctuations that surround it. However, the result of the correlation are like sloppy and unsatisfactory in various aspects. But for example, at tau equal to 6 months, it is observed that one peak jumps out. This peak implies that the comic book data from 6 months ago is connected to the MCU data, which makes sense because the advertising campaign for big budget movies like those in the MCU would begin around this time, with the publication of numerous trailers and television ads. And also as a result, like findings might imply that the start of this process has a greater impact of comic book sales than the actual release of the movie. There's also a peak around tau equal to 0, which corresponds to the film's release month, but it blends in with the plot's background noise, so we cannot like really infer anything from that. And of course, correlation does not indicate causation, but at the very least, the correlation data provided above like is consistent with the hypothesis that we started with, that MCU films influence comic book sales. Going forward with some cross-correlation and control metrics, we see like cross-correlation of MCU earnings and IWD Comics earning data as a function of tau. The shift between the time series happens here, and like again peaks here give the high correlation like metrics. And one thing we can observe, like even the peak at tau equal to 5 has comparable noise, and there are even several stronger peaks near tau equal to minus 55. And as a result, it can be asserted that the correlation peak mentioned in correlation section is really real. Like it's not something just hypothesized. It kind of moves towards a more proved phase, and it accurately represents the impact of comic book movies advertising on comic book sales. The future directions of like these all results, like I really want to discuss that. Like the analysis provided in the preceding sections like include a number of aspects that are planned to be carried out in future. Like firstly, to begin with, noise in data makes it difficult to separate the peaks that are found in the cross correlation from the background. And while the study of the control data set in the preceding section strengthens the assertions, the connection remain really weak. And like secondly, just following up with the first point, the fact that the time axis is only accurate on the month level creates a resolution issue. So there are different granularities of time series like hourly, monthly, daily, weekly. And for a more solid proof or like inference from this data and this research, we can obviously move forward with trying different like higher resolution, maybe daily comic revenue statistics, and it might reveal more compelling patterns. And it's also possible that the surge in comic book sales lasts shorter than like a month, causing it to be lost in the monthly graphs. Thus, more granularity of time series data need to be considered for future use cases. And of course, like the amount of variations that impact comic book statistics is another big source of inaccuracy here, because this study like kind of ignores seasonal oscillations. Like summer is a high earning month for comic book, but we are not considering all those factors there. So like obviously like a more robust model could be built, but this really shows that something is happening, like some correlation is there, and it might be like eliminated using a notch filter. We can use some things like that. Like conclusive ending would be that the findings in the study do not concisely provide or disprove the hypothesis, but like it is discovered that some pieces of credible evidence would undoubtedly spur further research into the subject. And it is first discovered that filtering monthly comic data indicated a significant visual relationship between the wide growth in comic sales throughout the 10-year research window and the release of MCU movies during the same period. And the cross-correlation results imply that the build-up of the release of MCU movies, like perhaps advertising campaigns and such things, might be quantitatively connected to comic book sales. And like overall, this research demonstrates a creative use of Fourier transform series like filtering, correlation techniques, and the impact of big budget blockbuster on like source material is of course like broader than comic books, an important topic in itself. And like just I like to end by saying like movies can be anticipated to boost interest in the comics for minor characters, especially in the Marvel universe. For example, Doctor Strange, maybe perhaps. And yeah, thanks a lot for your attention.
Thank you so much, Ashwarya, for your interesting presentation. It's really interesting to see the data set that you have used, the Marvel Cinematic Universe that you have mentioned, and the Marvel comic book sales. So the two time series data set that you have used for finding the causality by using Fourier transform, a very interesting topic. I hope by your research, Marvel have to rethink when they have to they dish out the film and their comics in the industry to get more profit out of both of the streams. So coming back, is there any question from the audience? Because we are running out of the time probably, that I'm getting a note from my organizers. We will welcome any questions from the audience, please. I think I can start with the question, Ashwarya, that can you please provide more details on how do you detrend? Like, is it filtering out some low components, or what is the procedure of doing that thing? That will be really interesting to know. If you can please provide some details regarding that.
Yeah, surely. So, like for retraining, like we usually, like every time series, as we know, like using the ETS modeling or the ARIMA modeling, like it has a different error series or different trend series and different like seasonality. So like, and along with that, like you also have some noise data and other things. And like, so basically, it can be additive in nature and it can be multiplicative in nature. And detrending just means that you're subtracting those components, like in case of additive nature, and you're just subtracting that, like you're not multiplying those in case it is multiplicative in nature. And those things like can be done like if you're just viewing different components in a separate like analysis, and like that's how you start with detrending. And basically like filtering also helps to understand if like a detrend is needed or not, because like filtering you can see the noise control and other things in the data, like if they're present or not. And like it's really an interesting topic of its own. And like mostly like the horse winter modeling would be helpful to detrend a series.
Okay, just a quick question regarding that. How do you keep a balance that no valuable information is lost out of those once you're detrending or you are filtering out some frequency components? So how do you manage that thing in your in that process?
Yeah, surely. So like that's like a bit complicated, but like you can just rest assured that like if you're just seeing no seasonality, and like if you're just like maybe having a polynomial fit of the time series, then you're good to go. Because like if a seasonality is present, then you'll just get to know that like there is a general increasing trend over the duration of like maybe 10 years. Like that's the data we use here, as like one would predict based on polynomial fit. And from eyeballing the raw data, like that's the most best thing to do. Because even like for detecting anomalies and like detecting like a anomalous pattern, like algorithms can help, but we can always use like eyeballing. And suppose like there is a rise in or a dip in the data, then that appears to be related to the number of MCU releases, or like rather going into details about like quantitative elements, like you can just focus on like correlation analysis.
That's really interesting. Means it's a really interesting topic that you have selected and presented in this conference, dear. I'm just waiting for any audience to come up with any questions for an interesting topic that Mr. Ashwarya is presenting right now. I think we are all set for this session in next couple of minutes. My last question is Shreya, before we call up from here, that is there linearity or non-linearity? How do you compare both these things in your research, linear and non-linear part?
So yeah, so I was seeing like when we use a different granularity, like for daily granularity, there was some linear relationships, and that like needs to be further explored, because like this one is based on like monthly granularity, and obviously like for monthly summations and aggregations, we just cannot concentrate on what the values would be, because suppose like on the day of release, like we can have a huge spike or dip, but that is all concentrated in like an aggregated manner here. So that's definitely one thing that we still need to do as a follow-up, and like most probably I'll be like doing some research for that.
That's great. We had a very interesting topic again. And thank you so much for presenting, Shreya. We will move forward to the closing of our session, this present session. With this, I will officially close the machine learning session day one. Thanks again to all the authors and participants for attending the session. It has been a really interesting presentations which were regarding the weather classification, the drone-based object detection, sentiment analysis, and of course the causal interference and causal inference in the time series data. So thanks to all the authors and participants for attending. All of you are invited to meet in the breakout rooms for each paper so that you can continue the discussions with the presenters if you want to. The participants hopefully will be present in those breakout rooms. Next, we will have a presentation regarding predictive maintenance based on the adaptive outlier identification in sensory vibration measurements. This is being given by Dr. Inns Michael Kozalski. He is from the Lucasius Research Network, which is an Institute of Innovative Technologies, EMAG. So I would like to thank all the sponsors and organizers of the MIDI 2020. With a closing note that while Omicron variant is already around the corner, so we are waiting for a normalcy in this world, which is again the old normal. And we want to have a pandemic-free world, everybody. So stay safe and see you all soon next year on the same platform. Thank you so much.